This conference will now be recorded.
Fine. Fine. We are going to write the statements what we want to print on the screen. Okay, we are going to write the statement hello world that needs to be printed on the screen inside the main function, and each and every statement present in the main function will be ending with the semicolon. That's it. Okay, don't get confused. The C language is very easy to understand. Okay, now we have written the source code now. Okay, we have compiled also. While compiling, what we have noticed is like we are going to check is there any error or not, and the compiling, what does the compiling do is actually it will try to change these statements into the statements the system can understand. The compiler will convert these statements into the statements how a system could understand. Okay, that is what the compiler will do. Okay, how the compiler will do, and after compiling how that particular file will be and where it will be, in the sense it will be stored in the C drive itself. We will see where it will be later. As of now, this hello world.c is the file name. We are going to save it. Okay, now here this particular file hello world.o, that is called as object file, it will be created by the compiler. This file will alone be read by the computer. We cannot open the file and we cannot read the file. If you try to open that file by using any other source, the content in the file will not be understandable to the human being. Okay, so it is called as the language is understood by the system. Next, what we are going to do, we are going to simply run the program. Control F9. I have run the program twice, so it is the result has been displayed twice now. So the linker is simply nothing but the okay, executable file here. So it will run the program and it will give the result on the screen. Hello world. That is what actually, nothing more than that. Okay, this terminologies we have seen, and these are the topics what we are going to cover. Okay, in introduction topics, the basic things. Next, under conditionally all the statements we are going to different statements. What actually the condition means our different conditions. Okay, is we will have going to some small area by some uh, thing if a person to buy a shop. Okay, and if he finds that the available some suppose why is not available in the shop native for that particular product to be. So in mind like shop to be open if it is if the A product has A in the shop is product
Sir, your voice is breaking, sir.
will help in having such type of these conditions help us. Okay, yeah, we will see while writing what are these conditional statements and loops. Next, arrays. Arrays. We wrote these arrays also actually. Variable, for example, is it okay now? Is it okay now?
No, sir.
Can you hear me, ma? Can you reply me, please? Can you hear me now clearly? Is it okay?
Now
Still,
it's fine.
disturbance is there.
Now it's fine, sir.
Now it's fine, right? Okay, I think some sort of network problem due to the rains. Okay, fine. We are having some sort of we are having array as a topic here. Okay, now what actually the array is? Array is simply nothing but it is a type of a data type or a variable which can hold multiple variables or multiple values in a single variable. Now here we are declaring the int a. Okay, here integer is of data type and a is a variable. Okay, and we are giving value 5 to the variable a. Okay, so we are doing some sort of a declaration here, and this particular declaration is called as a local declaration. Okay, this particular declaration is called as a local declaration. Okay, a is a variable of integer data type. Okay, and we are passing value 5 to the variable a. So what we need to understand here is that we are declaring the variable a, and we are passing the value, or we are initializing the value 5 to the variable a of integer data type. Okay, now in integer variable a, we are having only one variable, right? If we want to pass more than one value into the single variable, we are going to use arrays. That is what this concept is. Okay, we will see while using arrays and all, we will discuss about that. If I discuss about that now, you people will be getting confused. So I don't want to start that topic. Next is functions. Next, structures and union. This is also some sort of functions, pointers. This is for accessing the memory location or the variables present in the memory. Okay, we will see that one also. Next, data types. Mainly data types are of two types: primary data type and derived data type. We are having some sort of predefined data types, and the predefined data types are called as primary data types. Means we will be having some sort of standard data types. The standard data types what we are using are like int, short, long, float, character, double, long, double. Now we have seen only one, int, right? Such that we are having many other types of data types. Okay, we are having many other data types as predefined data types. So those data types are called as a primary data types or standard data types or built-in data types also. Okay, and some other data types are called, I mean, other type of data types is there, and they are called as a derived data types or secondary data types. Why we call it as a derived data types means we are going to create that particular type of data type. Here, integer is a predefined data type. Okay, we don't want to create a data type. Here already the particular data type is present. We are going to simply access it by using the keyword int, and we are going to declare the variables, and we are going to pass the variables, and we are using it. Similarly, if we want to create a new data type such as arrays and all, we can create it. So we are having some other type of data type which is simply nothing but a derived data type or secondary data type. Okay. The common data types, mostly commonly these type of four data types will be used anywhere. These other derived data types will be used very less actually. We have seen this slide yesterday. Okay, one bit is simply nothing but a binary digit. Why we call it as a one bit and binary digit is like whatever you save in the computer, it will be getting saved in the form of ones and zeros. So either 1 or 0 is present in the system. It occupies a 1 bit of size. Okay, 1 bit of size. Yesterday, I mean day before yesterday, we have seen some example. Okay, measurement of water. Okay, measurement of milk will be of will be in the form of liters. Okay, similarly, the memory present in the system will be having some sort of measurements. Okay, we call it as the bits or bytes or kb or mb or gb or db. Okay, how many bits will make a byte is like 8 bits will make 1 byte. Okay, 1024 bytes will make 1 kilobyte, 1 KB. Okay, 1024 KB will make 1 MB, 1024 MB will make 1 GB. Okay, similarly, 1024 GB will make 1 TB. 1024 TB will make 1 terabyte, like that. The highest measurement of the memory as of now is like a gigabyte or gigabyte, whatever you might. Okay, now you people might have seen your smartphones like you people are having 4 GB RAM and 64 GB inbuilt or 32 GB inbuilt, right? So it is a measurement of the memory that is present in your phone. Okay, you can use it for storage purpose. Now we have seen some sort of data types here. Okay, predefined, I mean primary data types and derived data types. We are going to discuss only about the primary data types now. Okay, and in program, you people have seen, we will see, we will try to write the here. Value of A is percentage D, comma, A. So what does this do is actually this particular statement will print the value of A onto the screen. Okay, now I will compile it and I will run it. Compile, run. Compile, run. I'm going to print it in the next line. Slash n I have used to print the statement in the next line. Slash n, it denotes n will denote like a new line. Okay, n denotes for new line. Just keep in your mind. We will see about these uh, things and all in the next coming slides. As of now, slash n will denote to print the statement in the next new line. Okay. Okay, here what we are going to do is we are simply going to print the value of the A. Here value of A is 5, that's it. So what we have to notice here is we have declared a variable A and that particular variable is of integer data type. Okay, and that particular variable is having a value 5 inside it. And we are supposed to display this A value on the screen. Okay, I said already whatever the content I am writing within the double quotes in the print statement will be displayed as it is. Okay, now I have used some other thing called as format specifier, which is simply nothing but a percentage D. Okay, if I wanted to display integer variable on the screen, I must use percentage D here and comma A such that the A variable content will be displayed on the screen. Okay, now for example, if I am going to uh, remove this, you can see what is going to happen. Did you find the A value printed? No, A value is not printed. Okay, if you give like this, the A value will be printed. See, right? If you want to print A value of integer data type, you are supposed to give the format specifier percentage D. Please remember these terms. We need to use the format specifier percentage D for the integer variable. Okay, and we will see here. Now this is of one data type, integer A equal to 5. Okay, now we will see another data type, float. B equal to 2.5 or 2.2 for your clarity. Okay. Now I want again this to be displayed. So I will write print f of slash n to make it displayed in the next line in the output. Value of b is, here we are using float type for fraction values data type. Okay, this data type is called as float. Okay, for integer type of values, there will be no fractions. Okay, no real values will be accepted. If you want to pass the real values into a variable, that particular variable should be of float data type. So you need to give percentage f followed by this double quotes, comma, b, close it, semicolon. Okay. Now what we have did here is, I am explaining again. We have declared the two variables, okay, a and b. A variable is of integer data type. B variable is of float data type. A variable will hold the value of integer numbers like 1, 2, 3 and all. When it comes to the B variable, it is of float data type. It can hold the values of real numbers or fractional numbers, like the values having the decimal numbers, okay, 1.2, 2.2, 3.2, whatever the number could be. It will hold the values of decimal values or fractional values or real values. We call it in different terms. Okay. Now I want to display this particular B variable also. So I have written the same statement here, but I have changed the variable name here and I have changed the format specifier here. Why? Because the for the B variable is of float data type, not integer. Okay, so F should be given here in place of B, and I have given the variable. I will compile it now. F9, control F9. See, this is the result. Value of A is 5 and the value of B is 2.2 followed by 5 zeros. Why the result is like 5 zeros followed by 2 is like whenever a fractional value is displayed, whenever the float variable is displayed, it will hold 6 values after point, after that dot, 2 point followed by 6 digits. Okay, it is default, no need to worry about it. Okay. Similarly, we will see some another data type, char c equal to a. Okay, now character, we are declaring the variable c, okay, of data type character, and the c variable can hold the characters. That is, they are simply nothing but the alphabets a b c d. It can hold. Okay, so whenever you are passing the variables into the variable in the variable c of character data type, you are supposed to give the single quote for the character what you are declaring and what you are initializing, such that the variable can be, the variable can take the value, or the variable, this particular value will be assigned to the variable c. Okay. Similarly, I will print this variable c now. Printf of /n value of c is. Now I want to know what actually the specifier would be, format specifier would be. Why? Because we are using the character data type here. So percentage c followed by comma and c, close the brace, semicolon. That's it. Okay. Now what we did here is, we have declared a variable c of character type. This variable c can hold the values of alphabets, character type. It can hold only a single variable, cannot hold more than one variable again. If you want to declare a and b, if you want to give a, I mean a b, I will write it here. If you want to write it like this and if you want to pass it, it is not possible. Why? We will see that. Okay. Now we are giving A and we are moving this A into C, and I will compile it now. No error. C. Value of A is 5, value of B is 2.20, and value of A is C is A. Okay, now I will pass like this. We check what will happen. Compiling, no errors. Running it. What happened? This one. I will give this statement so that you can see the current output alone. CLR is here. It will clear the output screen and it will print the current program's output alone. Okay, clear screen statement will clear the screen and it will print the current programs what you are running output alone. Okay, compiling. See, value of A is 5. B, what happened to B? Some error. If I use the CLR SCR, it is not supporting. Some sort of things will happen actually in this type of editors. Nothing can be done. Okay. Value of A is 5. Value of B is a 2.2 followed by 5 zeros, and value of C is A. What we have given here for C, we have given A and B, but character char C, the variable C is taking only one variable as input A, even though we pass the two variables A and B into C. Why? Because the size of C will accept only one variable at a time. The first variable will alone be taken as input and the rest will be removed. Now see this. I am going to give BA. What is typing here? What is displayed here? B. The first variable will alone be taken as input and it will be displayed. Okay. Fine. Now we will see what actually this slide is actually. So you can. So we are going to have different types of data types here and their format specifiers. Now we have seen the integer type and its format specifier is %d. And we have seen another type of character, okay, char or simply signed char or char. It is called as %c. Okay, we have seen float and we have mentioned it as %f. We are having many other data types here. Okay, we will understand what are they and why we need to have these different types of data types here. Okay, in the coming slide you will understand. Now see this. We have seen this type of data type now. Okay, int integer. We have seen this type of data type. Okay, and this integer can hold or will require 2 bytes of memory space when you are declaring a variable. Now, I will go back to the program. Integer A, right? What I am saying, integer will occupy 2 or 4 bytes. What is this 2 or 4 bytes? 2 bytes will be occupied in a 32-bit system and 4 bytes will be occupied in a 64-bit system. Okay, in general, you simply understand as per the old standard, the integer will hold 4 bytes of data whenever you declare a variable. Okay. Now you are declaring a variable A. This particular variable A will be allocated 4 bytes of data in the memory in the system. So if you are going to simply declare int A will be getting memory of 4 bytes. So this 5 value will be stored in A of 4 byte size. Okay. Similarly, character. Similarly, character. Character will hold 1 byte. Why 1 byte alone in the sense? This character will take input of only one character form. Just now we have seen cat C equal to AB, or we have given BA. Even though we give more than one character at the same time, it will consider only the first character as input and it will display it. Okay, so only it will display the first character, so it takes only 1 byte of size in the memory. Okay, similarly, we are having unsigned characters. You people can get it out. What is this char and what is this unsigned char? This character can hold even the negative values. Okay, but unsigned character will hold only positive values. Okay, this signed char are both same. It is been written twice. No need to worry and no need to get confused. Int, it is going to occupy 4 bytes and its value range is from -2 147 483 648 to positive somewhere. Similarly, unsigned int is there, it will hold only positive values, no negative values. Okay, short int, it holds both positive and negative values again. Okay, for large numbers, it holds large data types. Okay, this integer is of a small data type size, whereas short int can hold more values of data. Okay, that's it. Next one is a float. Float variable is there, float data type is there. This float data type will also hold a 4 bytes of size and its value range is like 1.2 e to minus e power minus 38 to 3.4 e power 38. Like that. It holds 6 decimal places. Just now we have seen the result, whatever it has been displayed for float, after decimal value, 6 values will be displayed, right? I am running the program again. So 2 point, so we are getting some error again. The compiler is creating problem. So after decimal value, we are going to get 6 values here. Okay, we are having some another data type called as a double, which can hold 8 bytes of size, and it can hold 15 digits after the decimal point, whereas float can have 6 values after the decimal point, and double will have 15 values after the decimal point. Whereas in long double, it can hold 19 decimal places or decimal or values after the decimal. Next one, what are valid and invalid identifiers? Identifiers are simply nothing but variables. Okay, here we have declared a variable, we have declared a variable, we have declared b variable, we have declared c variable. This a, b, c are called as identifiers. We are going to see which are valid identifiers and which are invalid identifiers. Okay, valid identifiers can be of single character type, either it could be of capital letter X or small letter X, whatever it could be. Okay, and a identifier could be of more than one character ABC. Okay, now I will write it. Int ABC equal to 5. So ABC. Compile. Error, it is showing some. One second. Unterminated string or character constant. Is this error? Compile is creating problem. Sorry, this is a purely compiler problem. Okay, we will see this slide and we will. I will try to change the compiler. Okay. Okay. A valid identifier could be of a single character. It can be a combination of more than one character. We can write it like this. We can even write it like this. Okay, simple interest. They are two words. Simple and interest are of two words. But we are not supposed to give a blank space in between the two words. So we are giving the underscore symbol here. You can use a hyphen symbol also. It is not at all a problem. You can use any special character. Okay, and you can use this type of formats A123. You cannot use the number first and followed by the alphabets. Okay, see here, it is invalid. 10 ABC is invalid. This type is invalid. Hyphen is invalid. Okay, this is also not invalid. Why? Because you are not supposed to pass a group of characters as input. Okay, that too in double quotes. Okay. Next, list. Capital letters is accepted, underscore is accepted, everything is accepted without spaces. These type of special characters are not allowed here, and these type of braces are also not allowed here. So we need to understand, when declaring a variable, strictly the variable would be of in this format, not in this format. So we are having some sort of valid identifiers and invalid identifiers. Okay, we are having some rules here. Identifiers can contain combination of digits, characters, and underscore. Okay, identifier names cannot start with digits. See here, A123 is there. 123 are digits and A is of character type. So this is invalid and this is valid. Okay. Keyword cannot be used as an identifier name, and uppercase and lowercase or a string. Fine. I will say this and I will conclude the class today. Okay. Keywords are simply nothing but integer, float, characters or keywords. Okay. Printf is also a keyword. CLR SCR is also a keyword. GetCH is also a keyword. Main is also a keyword. Means the functions or some sort of predefined things that are defined will be considered as a keywords. They cannot be again given as variables. Okay, they cannot be again given as a variables. That is what we are coming to say here. Nothing more than that. Okay, so we are having these three kind of rules here when we are declaring a variable in C. Okay, I will explain these 3 points again and we will stop the session. Okay, identifier can contain combination of digits, characters, and underscore values. Okay, and identifier name cannot start with a digit value. And the third one is the keyword can be used as an identifier name, cannot be used as an identifier name, and uppercase and lowercase or distinct. Now, I am using the ABC 5. If I write like this, small abc is one variable, capital ABC is another variable. Okay, we will see this example tomorrow. Why? Because I'm having compiler issue. If I compile it again, it will show, it will throw us an error. So we will see this point tomorrow and we will continue the class. Okay. Okay then. Thank you guys. We will see tomorrow. Sorry for some sort of disturbance due to rain and all and compiler issues. Okay, we will see the class tomorrow much clearly. Okay, okay guys, thank you very much.